Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to write balanced equations for combustion reactions. So let's get into this. So the first thing you got to understand is that when we're talking about combustion reactions, we're talking about any reaction that is reacting where one substance is reacting with oxygen. Oxygen is one of your reactants. Another reactant is some other compound. So in this video, I'm going to focus more on the organic molecules like hydrocarbons and things like that. So when we're reacting oxygen with a hydrocarbon like propane or butane or octane or things like that, um, you have to realize that if we're going to assume complete combustion, which is what we're going to assume in this video, then the products that are formed from your hydrocarbon, and that is anything that has carbon and hydrogen in it, and maybe even oxygen as well, the products are always going to be carbon dioxide and water. So those are the products of complete combustion. If there's something other than carbon, hydrogen, oxygen in there, then it'll be hard to say exactly what the compounds of those elements are going to be in reaction to oxygen, like sulfur, for example. But in this video, we'll just assume that the product for sulfur will be your sulfur dioxide. So let's get into this. So the first thing you want to do if you're given a substance and you're asked to balance a combustion reaction is to write out the combustion reaction. So we know that the other reactant is oxygen, and if it's just carbon, hydrogen, and oxygen, then we know that the products must be carbon dioxide and water. So we just write that out and balance it. So we have C8H18, which is octane. So we're going to add oxygen gas to that, and then that's going to react to form carbon dioxide gas and plus water. A lot of times you'll see the water as water vapor or gas, and that's because, well, if we're producing this by burning it, right? So that's pretty much what we're doing, burning it. Well, there's going to be a lot of heat. You're not going to produce liquid water, it seems, right? So a lot of times you'll see this as gas. Sometimes they'll write it as liquid. It doesn't really matter. I'm going to write it as a gas. So now we can balance the equation. So that's our combustion reaction. So now all we need to do is balance it, and we balance it like we normally do, following the steps. If you don't know what the steps for balancing your chemical reactions or chemical equations are, then please follow my video, watch the video on the steps in balancing reactions and the examples I go over. But I'll go over the steps, I'll follow the steps here. So the step one is I want to balance metals, but I don't have metals. I balance metals first, no metals here. So I'm going to balance the non-metals, and I want to leave carbon and oxygen to last. Notice that I have oxygen as an element by itself, not part of a compound. So I'm going to leave that one for last. So oxygen will be last, and then I'll do carbon first, and then hydrogen after that, and then oxygen. So here I have 8 carbons. 1 times 8 is 8. So I have 8 carbons here. So I only have 1 carbon here, so I need a coefficient that when I multiply it by 1, it gives me 8. Well, that's going to be 8. So here I write a coefficient of 8. 8 times 1 is 8. I got 8. So now my carbons are balanced. Now I'm going to move to the hydrogen. So here I have 1 times 18 is 18. So I have 18 hydrogens here. And then on this side, I have 2 hydrogens. So I need 18 hydrogens. What times 2 gives me 18? That'd be 9. So 9 is the coefficient. So now my carbons and hydrogens are balanced. So now I go to the oxygens. So here I have 2 oxygens. Here I have 8 times 2 is 16. So I'm going to have 16 here. And then 9 times 1 is 9. So I have 9 there. So 16 plus 9 gives me 25 total. So I need 25 oxygens on this side. So what times 2 gives me 25? Well, that would be 12.5 or 25 halves. So let me move this over so I can put that down. So I can put 12.5 or 25 halves, right? That would be the same thing. Now my equation is balanced, but even though it's balanced, I can't keep the fraction there. I can't keep the half. I need to get rid of it. So I'm going to multiply by 2 to get rid of it, but I got to multiply everything by 2 to keep it balanced. So 1 times 2 is 2. So I'm going to put a 2 there. And then 2 times 25 halves is 25, or 2 times 12 and a half is 25. So I'm going to update this, change this to 25. So that's 25. And then 2 times 8 is 16. So I'm going to change that to 16. And then 2 times 9 is 18. I'm going to get rid of this. And I got 18 here. So now I have my balanced combustion reaction. Okay, let's do the next one. So here I have methanol. And so this is going to react with oxygen. So I'm going to, again, put O2 gas down. And that's going to form, again, I have carbon, hydrogen, oxygen. Complete combustion is going to be carbon dioxide gas plus H2O gas. Okay, so now I have my combustion reaction. I have the reactants and products. So now all I need to do is balance the equation. So here again, since I have oxygen by itself, I'm always going to have oxygen by itself since they're combustion reactions, because oxygen is one of the reactants. That is, by definition, a combustion reaction. You have to have oxygen as a reactant. So I'm going to save oxygen for last. I'll do carbon first and then hydrogen. So I have 1 carbon, 1 carbon. It's already balanced. I don't have to do anything. So now the hydrogens, I have 3 plus 1, that's 4 hydrogens. I have 2 over here. 2 plus what, or 2 times what gives me 4? That would be a 2. So I'm going to put a 2 there. Okay, so far so good. So now my carbons and hydrogens are balanced. Now I'm going to go to the oxygens. So here, notice I have an oxygen here and I have an oxygen here. So that's 3. Over here I have 2. So 2 from this carbon dioxide, and 2 times 1 is 2. So 2 plus 2 gives me a 4. So I have a total of 4 over here, right? And I have 1 plus 2 over here. So I need 4 over here. Now, I have 1 here. If this could be made a 3, that would be great. Then I would have 3 plus 1 gives me 4, and it would be matched. So what times 2 gives me 3? 1.5. So I can put 1.5, or I could put 3 halves, and now it's balanced. I have 1.5 times 2 is 3, plus 1 is 4. That balances out. Everything is balanced now. But I can't keep the half. I can't keep the fraction. I've got to multiply everything by 2 to get rid of the fraction and keep the equation balanced. So 1 times 2 is 2, so that's going to be 2 here. And again, 3.5 times 2, or 1.5 times 2 is going to give me 3, or 3 halves times 2 is going to give me 3. 1.5 times 2 is going to give me 3. So I got 3 oxygen molecules. Here I have 1, so 1 times 2 is 2. Here I have a 2, so 2 times 2 is 4. So I'm going to get rid of the 2 and put a 4. And now my equation is balanced. Okay, let's keep going. So here I have C3H7SH. Now I have sulfur here. So here we're going to assume in the complete combustion that we're going to end up with sulfur dioxide as an additional product. So in addition to the carbon dioxide and water. So here we'll have oxygen again as a reactant. And so now here we'll have 3 products. We'll have CO2 gas plus H2O gas plus, and we'll have SO2 gas. So now that we have our combustion reaction, now we just need to balance it. Since we have sulfur here, we can balance the carbon and the sulfur first and then balance hydrogen after that. And again, we'll leave oxygen to last. So let's go ahead and balance our carbon. So here I have 3 carbons. Here I only have 1. So 3 times 1 will give me 3 carbons. So now that's balanced. Now for the sulfur, I have 1 sulfur here and 1 sulfur there. That's already balanced. I don't need to do anything. Okay. Now for the hydrogen, I have 7 hydrogens plus 1. That's 8 hydrogens here. And I have 2 hydrogens here. What times 2 gives me 8? 4. So I'm going to put a 4 coefficient there. Now everything's balanced except for the oxygen. So again, here I have 2 oxygens. And here I have 3 times 2 gives me 6. 4 times 1 gives me 4. And 1 times 2 gives me 2. So I have 6 plus 4 plus 2. That gives me 12 total oxygens on that side. I have 2 over here, but I want 12. So what times 2 gives me 12? 6. So I'm going to put a 6 coefficient. And now I have balanced my oxygen. So now we have a balanced chemical reaction of combustion. And notice in this case, I didn't have to use a fraction to balance, so I don't have to multiply by a factor. Okay, let's go to D. So D, we have butane, and so that's going to react with oxygen. So we're going to write out our combustion reaction. So oxygen is again going to be a reactant, and that's going to produce, since I only have carbon and hydrogen, then the products are going to only be carbon dioxide and water. So I'm going to have CO2 plus H2O. So, oops, I forgot. This should be, give me some room. So this is gas plus H2O gas. All right, so now I'm going to balance again, carbon first, then hydrogen, and then oxygen for last, because oxygen is by itself. So I have 4 carbons here. I have 1 here. What times 1 gives me 4? 4. 4 carbon dioxides. Now my carbons are balanced. Hydrogen, I have 10. Hydrogen is next. I have 10 here. I only have 2 over here. What times 2 gives me 10? 5. So now I have 5 waters. So that's 10 hydrogens. Now my carbon and hydrogens are both balanced. Now I have oxygen. So I have 2 here. 4 times 2 gives me 8 oxygens from the carbon dioxide. 5 times 1 gives me 5 from the water. 8 plus 5 gives me 13 oxygens total on this side. So what times 2 gives me 13? That would be 6.5. So 6.5, 6.5, or 13 halves. So now the equation is balanced, but of course I can't keep the fraction. I got to get rid of the half. So I'm going to multiply everything by 2. So again, 1 times 2 is 2. And then, oops, wrong equation. Doing the wrong equation. Okay, here we go. 2. 1 times 2 is 2. 6.5 times 2 is 13. So I'm going to get rid of that half and put 13. 4 times 2 is 8. So there's an 8. 5 times 2 is 10. So I got a 10 there. So I can erase this now. And everything is balanced. Okay, next we have C3H7OH. So this one has oxygen in it, but we're going to treat it the same. Since we have carbon, hydrogen, oxygen, the products are going to only be carbon dioxide and water. So again, our reactant is going to be O2 gas, and that's going to produce carbon dioxide gas plus water vapor gas. Okay, we have our equation now, so now we just need to balance it. So again, we're going to do oxygen is last because it's by itself, and then we're going to do carbon first and then hydrogen. So carbon is 3. I have 1 times 3 is 3. So what times 1 gives me 3? That's going to be 3. Now my carbons are balanced. So here I have 7 plus this 1, that's 8. And then I have 2 over here. So what times 2 gives me 8? 4. Okay. Now the hydrogens and oxygens are balanced. And now I have oxygen. I have, what's left? Oxygen is left. So I have oxygen is last. Now again, I have here 3. So over here, I have 3 times 2 is 6, plus 4 times 1 is 4. So add those together, and I get 10. Now I have 1 here. If I had 9 here, 9 plus 1 would give me 10. So what times 2 gives me 9? That would be 4.5. So 4.5, or 9 halves, right, is going to give me the 9 that I need. So then I have 10 on this side, 10 on this side. Now it's balanced. But again, we got to get rid of the fraction by multiplying by 2. So 1 times 2 is 2. So we got 2 here. 9 halves times 2 is 9, or 4.5 times 2 is 9, same thing. So this is going to be 9. 3 times 2 is 6. And 4 times 2 is 8. And now I have my balanced equation without any fractions. Finally, last one. Again, we have sulfur in this one. So what our product will assume in complete combustion that our product with the sulfur is going to be SO2, not SO3 or anything like that. So we're just going to say our product, one of our products is SO2. Again, we're going to have oxygen as a reactant. Let me give myself some room here. So we're going to have O2 gas, and that's going to give rise to carbon dioxide gas plus, oops, let's bring that over. That's going to be H2O gas plus SO2 gas. Okay, so now we have our combustion reaction. Now we just need to balance it. So carbons, then hydrogens, or no, carbon and sulfur first, hydrogen next, and then oxygen last. So we'll start with carbon. We have 4 carbons here. 1 times 4 is 4. Here we have 1 carbon. What times 1 gives me 4? 4. So 4 carbons now are balanced. So carbon is balanced. Next is sulfur. I have 1 sulfur, 1 sulfur. So sulfur is balanced. And now the hydrogen. So second to last. So I have 9 and 1. That's 10. And over here I have 2. So what times 2 gives me 10? 5. So 5 goes there. Now the hydrogens are balanced. Finally, I can do oxygen. So here I have 2 oxygens, none over here. Here I have 4 times 2 is 8, so 8 oxygens. 5 times 0, or sorry, I'm sorry, 5 times 1 is 5. And then 1 times 2 is 2. Oops. Sorry about that. So here I have 1 times 2 is 2. So I have 2 oxygens. Add these together. 8 plus 5 is 13 plus 2 is 15. So I have 15 oxygens on that side. What times 2 gives me 15? That would be 7 and, no, that'd be, yeah, 7.5. So 7.5 or 15 halves. So now my equation is balanced. So all I need to do now is just multiply the equation by 2 to get rid of the half and keep it balanced. So 1 times 2 is 2. And then 15.5 times 2 is 15. Or 15 halves times 2 is 15. 7.5 times 2 is 15. So that's going to give me 15 oxygen molecules. 4 times 2 is 8. So I'm going to put 8 here. I'm going to move, don't need this anymore. 5 times 2 is 10. So we're going to replace the 5 with a 10. And then 1 times 2 is 2. And that, ladies and gentlemen, is balanced. So that, ladies and gentlemen, is how you write out your combustion reaction when you're only given the substance. Now, for the substance that if you have nitrogen or sulfur in your substance, then you pretty much have to be told what the product is for that nitrogen and sulfur. But if all you have is carbon, hydrogen, oxygen, then you can assume, unless otherwise told, you can assume complete combustion. And in that case, you only get carbon dioxide and water as a product. So that is how you do it. Thanks for joining me. If you enjoyed this video, if this helped you in any way, then please like the video, share the video, hit that like button. Also, subscribe to my channel, hit that notification bell. And when you do, make sure you click all so that way you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you have a problem you want me to go over, or a question you need answered, or if you have a concept or a topic you want me to cover, please let me know. I would love to do that for you. Thanks for joining me, and have a great day.